We're loading. We're loading. All right, we're in. I'm sure you could tell by that intense cabin sound that just came up not too long ago. There we go. Gotta turn down my mic just a little bit. Looks like I'm peaking at normal talking volume. That is. Um, am I like a little bit louder? I turned up the preamp gain on the microphone. I'm just hoping that that's a little bit louder. But let me look at my filters real quick and let me. I don't want to pass through a limiter, but here we go, a compressor, but I'll pass it through a limiter and we'll threshold down -2 dB and release after 60 milliseconds. That should be good. The compressor I've just turned off completely because I didn't like that sometimes when I speak and the game volume goes down, that's very nice for like an engine burn or something, but we're not doing engine burns constantly, and I just found it personally just a little bit more annoying. So hopefully I'm coming in just slightly louder, a little more loud and clear. Anyways, we can go ahead and get this show on the road. Let's just give a little bit of a test here. Good, that works. That's all in order. Now let's bust out the old notepad. Let's get the old YouTube chat up. Very clear. Good. That's good. All right, we're in. Let's pull up the Rtcc And the checklist, let's see where we're at. So we need to calculate a mid-course correction 4. How's that Rtcc looking? Looking pretty good. All right. Yep, I know you can't see it. I'm still getting everything set up. Calm down. All right, I'm showing SFP preferred over MCC3. Okay, here we go. Now I need to get the LOI2 time from the, yeah, that's right. I gotta actually pull up the old flight plans. That's what it is. Flight plan 8, sections 1-2, LOI2. Here we go. All right, we got it. We got everything. I think we got everything good. We got the flight plan up. We got all that nonsense up. Okay, so I think we are ready to start making our calculations here. So go ahead and get that on screen. Let's start with the initialization of the table. Auto update, 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 and update. Vector panel summary, downlink, and we will target AS503. Time of ephemeris update will be taken from DC. Yeah, well, I'm not made of money, so we'll think about that at some point. All right, now we can shrink that back down. Bring this back up. Let's get MCC4 on the table then. Translunar, mid-course processor, nodal targeting, column 1, undocked, nominal targets. Looks pretty good there. Let me just double check that I've got everything input correctly. Yep, option 1, SFP2. Okay, good. Calculate. So it's a 1.1 foot per second burn. Let's transfer that over. We're going to use command module thruster configuration 2. Command service module thruster configuration 2, that is. We'll take number 1, do not iterate, CSM, looking good. Calculate. Calculate. Hello? Oh, I forgot to set you to active. There we go. Ha. All right, pings, external delta V, 1, don't replace. Here we go. Everything looks good. Calculate. I don't trust used electronics. All right, we got that on the table. 610923 is our time of MCC4. Let's just double check that real quick. MCC4 is... ...61 hours. That's right, because it's 8 hours before LOI. So 610926. Yeah. Let's just double check that as well. MCC displays MSK 82. Let's get U01, column 2, GET option. We could just choose a time in the future, 60 hours. Parameter 00. Okay, so 690926. Okay, perfect. We got that all good. Yep. All right, so that's good on the table. Next up will be lunar orbit insertion. So this one's going to be kind of an interesting one that we're gonna have to go with. Yep, here we go. So we've actually got a lunar orbit insertion calculator. LOI is going to be at, oh, we need to recalculate how that changes things. I don't think that after MCC4 that's going to change much, but we will trust but verify. So U01, column 2, GET, after, let's go with 62 hours. Yep, 690926, so still good there. So targeting, lunar orbit insertion. We'll integrate our vectors at 69 hours. We'll insert into a 170 by 60 orbit. Delta V's don't need to change. Oh, that's good. LOI initialization. Hello, James. Display. Calculate. Okay, so Apollo 8 uses the plane maneuver. Let me just verify that. Yep, okay. So we need to choose one with the closest to 60 periapsis and the least amount of theta and delta V. Then we need to transfer that to heads down. Okay. All right, looks good. Okay, so if we take a look, we can see that our delta V at LOI 2984 and 2983 HPCs are both 60, and there is a negligible theta. So we'll just choose the one with the least delta V then. And that's going to be 8. So we will transfer number 8. We will do this, of course, on the SPS. And there's going to be no ullage for this initial burn. Optimum time of ignition, iterate, and calculate. So we've got that on screen now, 6907:20.4. 7 hours, 58 minutes in between. Very good. Now what we need to do is we need to click update. And we need to change M58 to be heads down because we want to look at the moon when we're coming in. It doesn't really matter heads up or heads down, but in real life it was heads down, and we just want to make sure that we get a nice, good view of the moon, you know? And S. I don't remember what S stands for, but just S for this. Here we go. And now just to make sure that that went through all proper like, let's go to pad, maneuver pad, calculate, CSM2, heads down. Very good. And last but not least, we'll need to calculate an LOI2. All right, so LOI2 is going to be maneuver targeting, lunar descent planning, do not simulate descent. Good. So this is going to be a here we go, descent orbit insertion, double Holman, power descent, pre-launch plane change, phase change. I think we go CSM single maneuver, and then we go circ DOI. Let's just check. Yep, circ DOI 60 nautical miles. Our TH1 is nearest hour before LOI2. So LOI2 would begin at $73 hours. And then TH2 is nearest hour after. So 73 hours and then 74 hours. So here we go. On screen again. This is Apollo 8, yep. So 73:00:00, and then 74:00:00. Let's just double check that real quick. Always in the mood for double checking everything. Looks good. Descent planning table. Calculate. Ooh, no result. Okay, hold up. Ah, we didn't choose a vector time. Hold up. 73 hours will be our vector integration time. Calculate. There we go. So to circularize, that'll be at 73:25:09.9. That's about 5 minutes off from the prediction. Delta V is 136.95. And our apoapsis 60.58, periapsis 60.04. And that looks good. Let's transfer that over. So this transfer will, of course, be performed on the SPS. Ullage now will be 4 jets 15 seconds because burn rules. Optimum time of ignition. Calculate. And we're looking good. Whew! I hope I got everything right. Like, I hope I don't need to, like, iterate on any of this. This... Yikes. Alright. Now we'd go update. We need to do M58. CSM. Heads down. S. I forget what S stands for, but yeah. And now we'll just double check that that's now pointing heads down. So if we go into maneuver targeting, or excuse me, not maneuver targeting, preliminary advisory data, maneuver pad, P30, calculate CSM3 is still heads up. No, not gonna do, M58, CSM, 3, BS, calculate CSM3, heads down, good. CSM2, heads down, good. CSM1, heads up. OLED, or 4 jets, good. Alright, now we need to do the refs mat. So LVLH at LOI2. LOI2 is 732505. So now if we go to utility, refs mat, we're going to select LVLH. At the time will be 732505. Calculate. Okay, so now with that refs map put in, check this out. If we go to pad, we go to maneuver pad, and then we go and we would calculate our CSM3. Notice now how that's basically 0, 0, but 180. We want it to be 0, 0, 0, right? Basically a preferred pad. So now instead of that configuration, now that we've loaded that, we'll use that current load, this LVLH, and then we'll actually just add 180 degrees to that LVLH by doing refs map from current attitude. Attitude will be 0 roll, 180 pitch, 0 yaw, and then we will calculate again. And that is our new refs mat. If we go back and we check our preliminary advisory data, maneuver pad, we calculate CSM3, we're now roughly 0, 0, 0. CSM2 is also roughly 0, 0, 0, and CSM1 is not in gimbal lock at all, and that's how you know we've got it made. Now we can start our uplinks. So first up, we've got a maneuver pad. We need to do a state vector update for the LM and CSM. So uplinks. First, it's the lunar module first. So display LM navigation update. Targeting. up back, actually, hold on. CSM nav update, LM nav update. Yeah, it's LM nav, CMC, LM nav, no, LM navigation update. Yep. The target. Why are we not getting a target? Okay. 100. Target. There we go. We got one for the CMC. CSM. CMC LEM. Oh, hold on. Deactivate the mission planning table that way. Calculate and come up here. Verb 37, enter, 00, enter. And here's our LEM update. Here we go, ready for the CM update. Okay. Now we need the external delta V. Target load is next. All right. C10. Vehicle type CMC. Maneuver number 1. From the command module mission planning table. Uplink. All right, it's going good so far. Okay, and now, last but not least, is the refsmat. CMC refsmat update. And we're going to take that from the current locker. And this is going to be desired. Let's just make sure that those values are good. 375632 789464 485 435. All right, looks good. Uplink. And that's it. We've got it all in the computer. Now at this point, we need to do a PC +2 maneuver pad and a PC +2 fast return maneuver pad. However, we are beginning to be out of time for all that stuff. So, yeah. Should we calculate those? That's the question. I think not, and the reason I think not is because we're just literally running out of time, so fuck it. We know we're not going to do a PC +2. So, yeah. Let's, we've got everything we need. Let's go over to, preliminary advisory data. Let's grab our maneuver pad, and let's calculate for CSM 1. And we got everything we need. We can go ahead and delete M62, comma CSM, comma 2, comma D. Wipe that out, and we'll leave that one there just in case we accidentally get rid of our pad, but we sort of got everything we need. So, battery charger off. It's a little dark in this corner. All right, we're good there. Terminate PTC. All right, preferred IMU alignment time. BMAGs rate 2. CMC mode 3. Off CMC. I like it on low. Ooh, a little bit of maneuvering is required. All right, 35129. Three four 3.4. And 339. The fuck you mean, program alarm? I can definitely see stars. Fine then. Wine, 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 wine. It's probably not enough stars within the dead band. No, there definitely is. I don't know what the computer is all freaking mad about. Can you get me star 7? You can. Okay, interesting. Yeah, whatever. Probably not enough stars within a 20-degree dead band. And here we'll just go with star 4. All right, nice. GDC align. All right, looks good. We're back in business. All right, since it's not gonna cost us anything to get into the attitude. Well, except time. Yeah, okay, we'll wait. Let's keep our fingers crossed. Keep our fingers crossed that this goes well. If after MCC4 we still have that 60 nautical miles parasynthian height, we're gonna be so good. I'm gonna be happy. Current mission time is, as you can see, 60 hours, 25 minutes, 28 seconds. We're kind of close to LOI, just a bit. Approximately 8 hours away. All right. If the computer shows the good times, 6109, 23. Oh my God, it did it. It did it. Okay. Delta V 0.91. Oh my God, it's in. Oh, woo. Holy smokes. Oh my gosh, it's actually in. Oh, no way. That is so amazing. Five, four, three, two, one. Mark. Uh, that's okay enough, I guess. We are doing an RCS burn. All right. I'm just going to turn auto off for this. Test caution and warning lamps. Lamps, 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 lamps. Good. Delta V test. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh my God, so much easier than re-entry. That EMS switch is just, the EMS hat is so much easier. Delta V is in. Now we'll set it from the pad. What do we got? 1.1. And the great thing is you could do a little bit of time skip in there to make it go just a little faster when you're right clicking. Okay, re2, CMC free. Auto RCS, select all 16 jets. All right, what's our weight data? 638. Oops. 63876. Proceed, proceed. Verb 46. Let's get into that attitude. All right. Did mission control calculate the 1.25-second delay between the transmission and the marks? The marks for what? Exactly. Star markings are entirely internally calculated. The 1.25-second delay is factored in for when mission control gives you countdowns. Yeah. That's factored in. But otherwise, there's no need to factor that in. It's a non-issue. All right. Now we hold this attitude until T-minus 20 minutes to the burn. A little bit of time skipping didn't hurt anyone. Not that much, though. I'm gonna get some water real quick. All right, I'm back just in time. All right, we got the star. The star is in. Oh, there's our target. It's getting pretty big. What are we looking at? Star 37? Very nice. We're facing the right way. These are all indications of good calculations on MCC's part. Yeah, MCC brought to you by me. I'm doing those calculations this time. There's a first for everything. We can't see it in the windows, unfortunately. The angle of our flight path, and also the fact that it's almost completely dark. All right, 10 minutes to the burn. Loading up RCS program. RCS program has come up with very, very similar attitude that we had. So again, more signs that everything looks good. Verify GDC and IMU alignment. They are good. We won't be able to see it until, like, we're right about to do LOI. I'm not even gonna lie to you. It's like, it's dark at the moon right now. Five minutes and counting.
Translation.
Okay. Uplink telemetry, command reset. PCM bit rate high. Tape recorder forward. Limit cycle off. EMS norm. Tape recorder forward. Tape recorder forward is forward. Record is record. So I don't know why the checklist was not proceeding on that.
Translation.
Here we go. 4, 3, 2, 1. Ignition. And cut off. Tape recorder forward off. Rotational power direct to off. EMS mode. Standby off. Translation control power off. BMAGs rate 2. Proceed. Verb 82. Verify altitude. Okay. Proceed. 00. Too fast on the 00 there. Stop. Reset. Verb 66. When Frank Borman got sick, he talked to the surgeon on a private medical channel. How is that set? Ah, yes. Okay, so this is actually quite easy. You record on the tape recorder, and then when you're done, you stop recording. So you set either this forward-backward switch to middle or the record switch to middle. And then you take S-band aux and you flip it to tape. And what that will do is it will actually it will beam the tape recording back to the ground. ECS, TLI, LOI, redundant component check. Switch to other suit compressor. Give us a regulator check. Good. So it wasn't a private channel, it was the tape dump. Okay. So we've done that. H2O controller secondary to auto. All right, verify accumulator looks good. Pump start. Discharge pressure is stable. Accumulator is stable. Evaporate. And we got steam. Good. Okay, so there's a 5-minute hold for this now. At this point, I want to say, Houston, where the fuck are we? So let's go to mission planning table. And let's delete M62 CSM 1 no vector. Excuse me. M62 CSM 1 delete no vector. M62 CSM 1 delete no vector. Oh, right, because it's in the past now. That's right. M62 CSM 1 delete no vector. There we go. Okay, let's figure out where we are. MPT initialization, auto, update, 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 VPS, TLM, DC, AS503, time of ephemeris, DC. All right, here we go. This is the moment of truth. Let's make it nice and big so we know it's important. All right. Houston. Yeah, where the fuck are we? Look at that. Time of closest approach is still 690926, and our height at closest approach is 60.46. That is right on the money. That's right on the money. Yeah, that's amazing to see, honestly. All right, after 5 minutes of glycol operation, it should be between 40 and 50.5 degrees. Evap out temp, that is true. All right, reset the valve position. Switch off the pump. We're not making steam. Pump pressure is coming down. Accumulator is coming back up. Very good. Yeah, any other questions you have? I would be glad to answer them. That was actually arguably one of the most unique questions that I've ever had on this channel about the tape dump. All right, let's see what our ground track determination puts us at. 61.5 nautical miles. That is 3 minutes before LOI time is. So no, that's good. This is all looking very, very good. $348, $315. Oh, actually, it did want us to set. Why'd I put 21102? Oopsies. 11102. Force of habit. Post mid-course correction 4, 348, 315. Seven. Hello, Owen. And Buzz Aldrin talk about his life story for 30 minutes. I've heard the tape dumps from Apollo 11 where Neil Armstrong was talking about how many times he pooped today. I bet you it was like -1 because they were fed the opposite of laxatives. That is uncomfortably close to gimbal lock. I'm not even gonna lie. With our current refs mat, though, that should be perpendicular to the sun. Let's just go ahead and get that verified. Uh, it's a thing, I guess. It's okay. Not the best. Right. What version of Orbiter are we playing? We are playing Orbiter 2016, revision 90 beta. Wasn't there a mission where they had 4 gimbals? Absolutely not. Gemini and Mercury. That's it. Gemini, Mercury, and the space shuttle. Other than that, no 4th gimbal. Little bit of lag there, a little bit of lag. Gotta remember, turn that PCM bitrate back down to low. Did we kill anything? Nope. No alarms. Everything looks good on the old environmental front. Okay. Make a save. Because I just checked out NAS for Orbiter 2024. It looks good. Yeah, it does. However, I'm probably not going to get it until there's just a little bit, well, until I'm done with this, basically. And there's a little bit more support for it. Probably I won't do it until after they remove the 2D panels. If we wanted to now, we could actually generate our MCC2 slow return and MCC2 fast return, or sorry, our PC plus 2 slow return and our PC plus 2 fast return, but nah, we're fine. Who needs to do an abort on a mission? Aborting is for people that don't know what they're doing. All right. Let's give the cryo stanks a tur. A cryo stanks a tur. Cryo tanks a stir. Cycle for 2 minutes. Oh, we're getting spicy with the cryo tanks now. I just finished Apollo 8 and started 11. Oh, you got to do 7 after 8. Oh, that's actually crazy. You're gonna start learning a new vehicle before you've even mastered one of them. That's crazy. I did all the missions in order, so I'm crazier. The Lem is weird. I love the Lem. It's my favorite. I used to like the CM more, but I flew the CM so much now. I love the Lem and I enjoy the eggs. Apollo 9 is like my absolute favorite mission of all time. It is so good. I do really like the LEM though. It's so fun. It really is, especially in Apollo 9. You plug in circuit breakers you never do ever again. You do procedures you never do ever again, like an eggs burn and a dock dips burn. It's just such a hoot. I mean, there's nothing to not love about Apollo 9. And I also really enjoy 7 for the same reasons as 9. It's just big system shakedown, procedures you'll never do ever again. Cool things like the rendezvous and all that jazz. Manual thrust vector control, SCS burns. It's just a hoot. Well, I think we're approaching the moon. The moon. We're approaching. For those not in the know, we are currently at T plus 65 hours, 30 minutes, and counting. Yeah, if you're in the NASP or Reentry Discord servers, absolutely. What time zone? I'm not going to give that away. However, however, um, you are usually online when I'm online. Just ping me whenever you're available, and if I'm available, I'll respond, and if I'm not available, I simply just won't respond. Okay, let's do the LOI 1 maneuver pad. All right, on screen, MPT initialization, auto, update, 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 vector panel summary. We've got good downlink. Our DC is going to be Apollo spacecraft 503, and our time of ephemeris will be imported from DC. Mission planning table is active. All right, let's double check our space digitals. U01, column 2, GET at 67 hours. Okay, 690926, 60.68 is our new HCA. So 690926. Maneuver targeting. Lunar orbit insertion. Initialization, 69 hours. Looks good. 170 by 60. Looks good. Display. Calculate. Looks good. Let's take... Let's transfer number 2 to the table, or number 8 that is. SPS, no ullage. Iterate optimum time of ignition. Calculate. Pad. Calculate. CSM 1. Oh, hold up. We forgot to update. M58. CSM. Heads down. No system parameter. Okay, recalculate that. Excuse me, update. M58 CSM. Maneuver number 1. Heads down. No system parameter. Okay. CSM 1. There we go. That's our pad. Hello, Foxtrot Bravo Aviation. Yes, see, also I'm moving soon, so giving away my time zone is going to be completely useless anyways. But it's mostly just I always operate off of different time zones, because I just like that no one knows, you know, even generally where I live. Although I suppose my home country of origin, which I do have on my channel, is a very small geographical zone, so it doesn't really make that much of a difference, but I just try to give away as least of that as possible because it's like being in like knowing about IT, it's like every time it's the little thing, the little piece of information that like wouldn't detail anything about you, except when you keep adding up all those little things, you can narrow it down and you can pinpoint exactly who. So like all of this data and stuff that they're saving on you, that they say is like anonymous, and it's like for purposes or research purposes, if you just combine those tables in the right fashion and in the right order, you can point out exactly who that person is, never having recorded any personal information about them. And that scares me. So the internet should rightfully scare you. Yeah, I do IT. What kind? General IT. I hope to work in networking eventually, working on like Cisco or something, but general IT right now at the moment. Good. Pre-LOI TEI 1 maneuver pad. Oh my god, I don't want to do all of that crazy stuff. I just want to get LOI done. Pre-LOI TEI. I mean, we could do some FAFO and try and calculate that, but I assume it's return to Earth on the abort scan table. But when we work on learning how to do TEI, then we can, you know, say that we know how to do this retroactively. Cybersec. I thought I was gonna go into Cybersec, and then I realized that it's actually boring. So I chose network. I just want to do networking instead. Yeah, it's just cybersecurity is just actually boring. There are parts of it that are fun, but no one hires offensive security anymore. No one hires the red team. They only hire the blue team. There's not a whole lot of job stability as the red team right now, so and being the blue team is boring. Really boring. All right, let's get ourselves into that LOI attitude. You like puzzles? Yeah, that's just the thing. That's I guess, but networking is more puzzly to me. All right. Let's maneuver, shall we? Uh, 358 00500. All right. Getting up into attitude. All right, we're in our LOI 1 attitude. Let's perform ourselves a sextant star check. If only I could be an astronaut. 0202. All right, sextant star check passes the test. Okay, map update. That's gonna be a new one. Is it a pad? Map update. Prime Meridian, oh, I don't know. GET is going to be after LOI 1, that's for sure. So let's do, yeah, pretty much 69. Oh, let's do 69, 20, 00. That should be enough time. The moon. All right, so LOS will be at 70:55:02. Sunrise at 71:01:30. Can we start it earlier than that, actually? Can we do right at LOI 69:07:21? Will that work? Yeah, okay. So loss of signal will be at 68:56:55 with sunrise at 69:09:26 PM. Assume that stands for prime meridian. Time of prime meridian crossing is 69:07:21. So a little bit actually before sunrise. Acquisition of signal at 69:20:33 with sunset at 69:09:26. Oh, that's interesting. Let's do a little bit after burn completion. So 7, 8, 9, 10, 11, 12, 13 minutes. Let's round that up to 14 minutes. See how that factors in. Loss of signal at 70:55:03. We definitely lose signal before ignition, so... Loss of signal is at 68:56:55. I think LOS and AOS are really all we care about. 68:56:55, 69:20:33, sunrise and sunset. Since we're not exactly like in a circular orbit, I don't think it's going to calculate those properly. Do I play DCS? No, I do not play DCS. I don't really play much war games. What have you missed? You missed absolutely nothing. In fact, I forgot to show it, but we just did a map update here. I was just fiddling around with this GET to get us a map update. How can we calculate our prime meridian? Actually, that would be good to know. Let's take a look if our Space Digitals has a prime meridian. Yeah, 174. That's the longitude of closest approach. Prime meridian. I think the default is fine. We haven't done any sort of crazy plane changes, so I don't see why the default would be any different. Velocity is currently 48 or 4,815.6. I can hardly believe that. Gonna have to recalculate. Looking at it, 13 hours or 13 degrees, 32 hours north latitude. Well, we've got a map update. It's in. It's not Probably not going to be the greatest since I have no idea where our prime meridian. I mean, 150 degrees. It's got to be just a default value. It's auto selected the moon, so I think we're good on that. Um, Coming up on battery charge termination here. Okay. Get that out of the way for you all. Battery charger off. All our circuit breakers are in. Battery manifold does not need venting. So our time of ignition for lunar orbit insertion is 69 hours, 7 minutes, and 21.11 seconds. Delta V of LOI is going to be minus 29794 plus 02474 plus 00469. Proceed. Let's take a look at this output. Let's see if she's good. We should get 170 by 60 with a total delta V of 29900. I don't think it's going to come up, or actually, yeah, I don't think it's going to come up yet since we're not in the lunar SOI, but 29900, that is exactly correct. Proceed. Proceed. 00. Get that back out of your way. All 16 jets enabled. Let's get the DAP in. 11102, 01111. Looks good. Proceed. Our command module weight is 638509. Our gimbal trim is minus 001502 plus 00127. Verb 46, enter. All right. SPS pre-thrust delta V test. Verb 37, enter. 40, enter. We've got our attitude in. Maneuvering to attitude. Looks good. Circuit breakers. Limit cycle on for some reason. At 1, rate 2. Rate command, auto. Battery power on. Thrust vector control servos. DHC on. RHC, AC only. Pitch 1, start. Yaw 1, start. Clockwise, verify. No manual thrust vector control is verified. Pitch 2, start. Yaw 2, start. Minus, plus, 0. Minus, plus, 0. Minus 1.5 plus 1.3. Up, down, left, right. Looks good. THC neutral. AC/DC. Direct on. Rate 2. Proceed. At 1 rate 2. Enter. Proceed. All right, everything looks good. Verb 37, enter, 00, enter. Come on, computer, thank you. EMEM dump. Gimbal power off. DVC servos off. Main bus ties off. Attitude deadband max. THC off. Direct power off. BMEGs rate 2. Pull our circuit breakers. And begin PTC for literally 30 minutes. What a useless PTC. I don't even know if we're going to get an attitude by the time we're through with this, to be quite frank. Right. Maybe it's probably a little bit longer than 30 minutes. It's probably not useless. It just feels that way since we are literally so close. But yeah, while we're maneuvering, I'm just gonna go use the restroom real quick. Alright, I'm back. Perfect timing. Alright, attitude dead band max, rate high, limit cycle on. And we are in PTC. Wait for LOI maneuver pad. Okay, so we're going to delete our preliminary pad. 62. There we go, I'll put that on screen. We're going to delete our maneuver pad. We're going to deactivate the mission planning table. And then we're going to go ahead and just bump up those 30 minutes. We'll give us a little bit more time. We'll give us maybe like 5 minutes. Get everything sorted out. Start our uplink. Okay. Here we go. So, mission planning table. Update. 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 Vector panel summary. We're still good on the telemetry there. AS 503. Time of ephemeris is in. Maneuver targeting. Lunar insertion. AS 503, 170 by 60. Calculate. Okay, so again, plane option 8 hasn't changed. Our height at Paracynthian is 60 nautical miles. After the burn, it's predicted to be 60.7. Delta V at LOI 2 is pretty low. Delta V at LOI 1 is reasonable. And we are burning for plane, so we'll transfer column 8. SPS, no ullage. Mission planning table, active. Alright, good night, Owen. I'll see you later. Send that to the table. Okay, so let's remember we gotta update this. M58 CSM down, no system parameter. Let's see if she's in. Pad, maneuver pad, calculate CSM 1. It still heads up. M58 CSM 1 down S. I always forget the maneuver number. I think that's what that was. CSM 1. Pad is in. Everything's on table and active. State vector updates are coming in now. Starting with the CSM this time. Okay. We've got our LOI-1 maneuver pad. We are just waiting on the old state vector update. Calculate. Uplink. Next up is a LEM navigation update. In order to do that, we've got to deactivate the mission planning table. Calculate. Uplink. And last but not least is target load. Just want to be sure of that real quick. Yep, target load last but not least. All right, C10. Going to the command module computer. Maneuver number 1 from the CSM mission planning table. Calculate. And uplink. Oh my god, it's gonna be so cool when we can actually chain together uplinks. Oh, I'm gonna recommend they add that. That's gonna be so cool, like they did in real life. It's gonna be nice. Okay, P-21 ground track determination at lunar orbit insertion. $69 hours, 7 minutes, 21.20 seconds. All right, apoapsis and periapsis were predicted to insert into a 169.4 by 60 orbit. That's exciting. That is exactly right where we want to be. Cycling cryofans for 2 minutes. Let's get stabilized. Okay. P-52. Star 3 and star 11. All right, activating primary glycol evaporator. H2O flow initialized. Steam pressure auto. Oh my gosh, what is up, Flight Streamer? Oh, so nice of you to make it. I'm sorry to hear about those BIOS issues. I was waiting too. I was like, oh, do I start streaming? Because like normally you're like a late night streamer, and I was like so excited to see what you had planned today. And then I didn't see any stream come up, and I was like, oh, something must have happened. So figured I would do this and then see if you were online. Had to be something. Yeah, very sorry to hear about that BIOS. I hope it's not any hardware issues. Have you tried reseating the CMOS battery? Like taking it out and then holding the power button down to drain the motherboard capacitors of their residual current, and then reseating the CMOS battery. It's gonna wipe all of your BIOS settings, so keep that in mind, but it's maybe like swift kick in the ass is what it needs. Okay, CMRCS meets pre-pressurization conditions. What's our lowest quad right now, actually? Curious. Looks like quad delta is the lowest. Could be quad. Yeah, quad delta. Quad Charlie may be actually the lowest by its virtue of temperature, but the quantity gauging system reads delta as the lowest. And all of our manifold pressures look good. So, oh, SMRCS check is scheduled anyways. Let's take a look. Helium tank temps look good. Quantities are good. Manifold pressure is good. Package temperature is good. And fuel pressures are good. Very, very good. SPS monitoring. SPS is preheated. Good. Fuel and oxidizer pressures are in the green. Helium pressure is good. Nitrogen valve actuator pressures are good. A little bit higher on Bravo because we did have, I think, one small SPS burn at some point. At least I pray we had one small SPS burn. I think we did. It was literally just like a puff of the engine. Like just on off. So, unfortunately, on off. That small amount takes as much nitrogen as a big long burn. So, here we go. Let's take a look at our surge tank pressure. That's looking pretty good as well. Tank 1 is, of course, in the green band. Green band does not apply for surge tank pressure, by the way, if you're curious. It's only for the main tanks. All right, fuel cell power plant. We've got good flows on all three. We've got good module skin temperature, good module condensate exchange temperature, so that's all good. We are outputting approximately 25 volts on fuel cell 1. I chucked that up to 24 volts on fuel cell 1, or amps that is. About 34 volts, 34 amps on fuel cell 2. 15 amps on fuel cell 3. Main bus A is reading 28.7 volts. Main bus B is reading 29.1 volts. Battery bus A is reading 34.7 volts. Battery bus B is reading 34.7 volts. Battery C that is reading 36 volts. Pyro batteries are, of course, reading none because we need to close the circuit breakers. Okay, we're reading 37 volts on the pyro batteries. That's exactly what we expect. And at this time, we have good battery relay bus voltage of 4.05 volts. No reason to vent the manifold. However, as a precaution for that specific sensor being broken, we will manually vent for lunar orbit insertion because we're about to expel a ton of hot gas. So if this sensing circuitry is broken on that manifold, we would explode. Absolutely required to vent this, regardless of if it shows 0 or not. Our AC power plant is reading very good. It's reading about 100 and 10, 11, 12, 13, 14, 15. So 10, 12, 114 volts across all of the terminals here. Very good. Environmental control systems monitoring check. Suit cabin delta pressure should be -1 to -3.5. We are currently situated at -1. Our O2 flow should be low scale up to 0.45, and we are at low scale 0.2, so that's good. Taking a look at our surge tank, should be between 865 and 935. Looks good. Tank 1 should be anything greater than 865. That looks good. ECS radiator talkbacks are gray. Yep. Primary indicator, radiator temperature inlet is about 90 degrees. Outlet is about 27 degrees. Very good. Glycol evaporator outlet is about 45 degrees. Pretty good. Steam pressure, we are making steam. We're boiling. And the discharge pressure is stable at 40. Suit temperature is good. Cabin temperature is a little chilly, but good. Pressures are good. CO2 is less than 7.6 millimeters of mercury. That's good. Suit compressor delta pressure is good. And the pounds per hour, of course, is going to read 0.2 because we don't have any O2 flow, so low scale on that. That is good. Accumulator levels are good on primary and secondary. Potable water quantity is good, and we do need to do a wastewater tank dump. All right, any questions? Big checks, big checks. Time of ignition is at 69 hours, 7 minutes. We're at 68 hours, 17. So if we do ourselves 7 minus 30, we get 23, 60 minus 23, and we get 37. So we're almost slated to start punching in those burn parameters. Look at that. The moon, it looks so big, yet so invisible. Oh, there's one thing I completely forgot about. We need to make sure that we don't have to dump our piss tank. 40.87% urine collection device. That's fine. Look at that. Oh my gosh. We are getting so close. I can't wait. It's going to be so exciting. My very first hand-calculated lunar orbit insertion. We're only doing LOI 1. I don't foresee myself having time for LOI 2. Darn Folgers, lol. What's Folgers going on about? Let's take a look. Oh, he's not going on about anything. Good. All right, so a little bit late on that T-minus 30 mark, but that's okay. Lunar orbit insertion 6907 21.2. Proceed. Minus 2979.4 plus 0247.4 plus 0046.7. That's good. Proceed. Since we're a little bit behind, we'll start our EMS Delta V test here. Okay, that looks good. Go to proceed. Oh, adding the piss tank, yeah. It's kind of a cool feature, I guess. All right, Delta V compensated for engine thrust trail off is 2974.6. Two nine seven 4.6. Looks good. Non-essential bus to main bus B. BMAGs rate 2. CMC 3. All 16 jets for this burn. Digital autopilot 11102 01111. Proceed. Command module weight is 63,857 pounds. And the trim is minus 1.52 and plus 1. Hello, can we change that? 001.27. I doubt we can change it. Yeah, it's a rounding issue. Okay. Verb 46. ACDC. Give our computer the old F5. And let's pop us up into burn attitude here. T-minus 23 minutes and counting. 001 00 35800 00500 CMC auto. Getting into burn attitude. No, I was 3 minutes behind. I accidentally time skip a little too much because instead of paying attention to the timer, I was paying attention to the waste tank, of course. So, whoopsies. Anyways, Flight Streamer, I hope you are going to enjoy this, since this is the moment you have been waiting for like 3 weeks now, maybe 4 weeks. And look at that. It's beautiful. We can see the crescent. We can see the spacecraft, the engine, the Earth, high gain antennas there. It's all there. It's very nice. Let me get all this jazz out of your way, though, so you can enjoy the scenery with none of this BS on screen. Yeah, this looks so cool. It looks awesome. How are we doing? 22 minutes to the burn? I think we can make it in time. Yeah, we're doing good. Okay, we can make it. For sure. I was all worried for nothing. There she is. We're in attitude at the proper time. T-minus 20 minutes. Let's get ourselves a sextant star check-in. So if we are in the correct attitude, we should be looking at star 02 when we punch in 237.42 and 20.788. This is not all the sextant is used for, Flight Streamer, by the way. This is a very bad demonstration of what the sextant is used for. It's used for a lot more than this. This is just a contingency to make sure that we're, you know, pointing the correct direction. So you haven't seen the optics at its best yet. Okay, transferring attitude control to major program 40. Verifying GDC and IMU alignment. Slightly off, but well within spec. Direct ullage circuit breakers closed. Pitch and yaw circuit breakers closed. Attitude deadband minimum, rate low, limit cycle on. All is rate command. Body mounted attitude gyros at 1 rate 2. SCS TVC to rate command. TVC gimbal drivers auto. Coming up on the T-minus 10-minute mark. Now that we got the famous flight streamer in here, we gotta do LOI 2, right? And all the cool landmark tracking, right? The famous flight streamer. Oh my gosh. Like it's really happening. Hand calculated. I cannot believe we got this far. Off of mostly fuck around and find out. All right, T-minus 10 minutes. Let's just verify our engine temperature is, yeah, it's still hot. Almost 100 degrees. Excuse me, did I say 100? Sorry, I meant almost 900. Yeah, no, because, no, that is almost 100 degrees. Okay, yep, nope. Sorry, yeah, we're good. Almost 100 degrees. Thought I was gonna lose myself. I was like, no way. Why would I need... This is the VOD that I will save. I've made no blunders with accidentally sharing my desktop. I've made no blunders with the calculations. I may actually save this fuck around and find out VOD. I may actually save this one. Okay, T-minus 6 minutes. Get those main batteries on the bus. Thrust vector control servos are on. Translation control power on. Rotational control, alternating current only. T-minus 5 minutes. Gimbal motors. Let's just give ourselves a clean board on the trim. Pitch 1 start. Yaw 1 start. Abort handle clockwise. Verify no manual thrust vector control. No manual thrust vector control is verified. Pitch to start. Yaw to start. Trim minus, plus, 0, minus, plus, 0. Trim is good. Let's set it up. Minus 1.5, plus 1.3. Manual thrust vector control is go. Abort handle neutral. Rotational control, alternating and direct current. Direct coils, main A, main B cross tie. Transfer the attitude control back to program 40. Attitude checks are good. Let's verify computer has control. Proceed. Let's look at that engine gimbal. Oh my gosh. So sweet. Computer has control. Trim load. Trim is in. There we go. All right, helium valves are auto. Limit cycle back off. Rate scale 50-15. T-minus 3 minutes. Let's go ahead and make that T-minus 2 minutes with a touch of time dilation. T-minus 2 minutes. Delta V thrust, main A normal. Pulse code modulator bitrate high. And let's start throwing things in the tape dump. Tape motion is gray. And we're recording on the old black box. All right, T-minus 35 seconds. Computer blank. EMS mode normal. And delta counters are live. T-minus 25 seconds. T-minus 15. Oh, look at the window. 12, 11, 10, 9, 8, 7, 6, 5, verb 99, proceed, 3, 2, 1, ignition, thrust pressure is normal, bank B on. T-minus 4 minutes to cut off. Now all we can do is cross our fingers and pray. Let's say we get a cool display going. Reference. Moon. Let's get one of these cool displays up. It's not going to be any view obstruction, but here you go. So you could see exactly what's going on. It's in metric, of course, so that's a shame. Because everything else is in standard, obviously. It's an American spacecraft, but... T-minus 2 minutes and 30 seconds to cut off. All right, velocity till cutoff, another 1,500 feet per second. (1,000 feet per second remaining. T-minus 1 minute, 12 seconds to shut down. Periapsis is remaining stable at 111 kilometers. That's about 61 nautical miles-ish. 500 feet per second till cutoff. $300. 20 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Shut down. We're in a stable lunar orbit. Okay, banks disarmed. Gimbal motors off. Thrust vector control servos off. Flight recorder off. Tape recorder off. Main bus ties off. Proceed. Residuals are 0.2 in Y and 0.1 in Z. No reason to trim. BMAGs rate 2. Attitude deadband max. Non-essential bus off. Trans control power off. Direct power off. Keeping direct ullage plugged in. Unplugging pitch and yaw circuit breakers. Proceed. What's our orbit? 170 by 60. A perfect orbit insertion. Beautiful. All right. Write that to our state vector. Stop. Reset. Welcome to the moon. Okay, copy our current state vector to the lunar module state vector slot, just because we don't have a LEM, so we can do stuff like that as backup. Engine, of course, just did a burn, so no reason to preheat it. Verifying helium pressure and nitrogen pressure is still A-okay. Quantity is at... So we took 40% fuel to insert into this orbit, and we have to circularize still. So just for reference, 40% of the fuel is now gone in one burn. Anyways, quantities look good. Injector valves are all closed. Helium valves are closed and in auto. Talkback's barber pole. Service module RCS. Quantity is looking absolutely spectacular for this phase of the mission. We've got plenty of gas to do all of our cool science, all of our cool maneuvering, our landmark tracking. It's going to be good. IMU and GDC are a little bit misaligned, but still well within the spec. Okay, let's calculate average altitude. Sphere of influence. Oh, let's get the ordeal up. There we go. Sphere of influence is lunar. Our current altitude is about 169.9 plus 60 divided by 2. That's about 115. Mode, hold fast. Deal set, body 1. Let's get the integral lighting up on the ordeal. And our current pitch angle down to the local horizon is 203.5. Let's get ourselves more stable so that we don't have a rough time punching this in. 203.5. Crossing 27207. Mark. Okay, looks good. Ordeal is set. And we are inertial. Roll right 180 degrees at 2 degrees per second and continue inertial attitude hold. Roger. Rolling right. Oh, yeah. Which box behind my head? Oh, this one, right? Yeah. I was gonna say, because if it's this one, that can't be, because that's where our oxygen is. Would be kind of bad if it went in there. Oh, damn, look at that. It's so beautiful. Look at that. Let's check our altitude. No, I'm just kidding. All right, let me get that checklist out of your view. Sorry I didn't do that earlier. All right. Our predicted acquisition of signal, if we remember, was 6920 33. So we'll be getting acquisition of signal very, very shortly. Let's acquire Houston on the high gain then. Verb 64. Enter. Well, we could at least position the high gain. Minus 85 plus 73. So 85 is about there. And plus 73. 90 minus 15 is 75. So yeah, about right there is about 73. Maybe just a hair less than that. And go manual. The angles are driving. Honestly, I highly doubt we're going to get acquisition of signal in... What was it? In about 30 seconds. I just don't see it. Let's do 69... 21... 20, that's fine. Acquisition of signal is at 692948. Okay. Oh, we made it. We are in our first revolution of the moon. All right. Actually, I do think we're gonna stop before lunar orbit insertion 2, and the reason is because I have to go and change my label settings. I bet if I popped up F9 right now, yeah. Okay, that's what I thought. Actually, can I see any of this stuff? Let's just double check real quick. Can we see it? Nope. Okay, so I've just got to go through and update all of this jazz. All right, acquisition of signal will be happening with a little bit of time skip right now. There it is. Oh my god, look at that. Acquisition at Honeysuckle. There's the Earth. Yeah, right? Like, I just finished changing that stuff. And then they were like, oh, hey, by the way, we just defaulted it to always being on. I'm like, great. Well, now I need to change all of that stuff again. That's the Earth right there. Beautiful as ever. Okay, let's see. Are we locked up? It's pretty weak. There we go. Now we're locked up. Tracker to auto. Oh, hey. If the flight streamer is still here, he could see the P-52 in all of its glory. Okay, let's turn our modulator back to low so we don't crash, burn, and die when we go and time skip. In the meantime, let's clear our mission table. So, mission planning table, delete. On processor M62, the CSM table, maneuver number 1, delete from the past. Deactivate. There we go. Very busy troubleshooting. Oh my gosh. Does your motherboard at least give you a light? Like, does it tell you where in the BIOS process it failed, what light is on? So if you would like, I can help troubleshoot pretty shortly, actually. We're going to stop the procedures here. Let me pull this up. So we're at 69, 36, 69 hours, 37 minutes right now. At 70 hours, 14 minutes with a little bit of time skipping. We're going to start a optics align, and we're going to do a purging on our fuel cells and then activating our secondary evaporator. And then after that process is done, we're immediately going to stop because I need to learn how to calculate trans-earth injection then. So boot LED yellow. Okay. That's actually not the most descriptive. I'll look into that. You want to message on your Discord server the model of the motherboard you have? Then I'll look at that as soon as we're done here. Shouldn't be probably another 10 minutes or so, 15 or 10 minutes. But that's sort of what's on the flight plan up to this wait for TI maneuver pad. Then we're going to stop because this is a new type of maneuver that I need to learn how to calculate. I skipped it last time because I just wanted to do LOI. So I skipped it when it was like sort of, oh, we're kind of like in between the moon and the earth. Now that we're fully in the earth, I want to learn how to, or fully on the moon, there's not a lot of time pressure for anything anymore. I'm going to take some time out to learn how to do that. So that's why we're stopping a little bit sooner than I thought. When I forced boot, it worked. Okay. Wonder if it's just reading corrupted boot files. Yeah, I'll definitely take a look into that. See if I can't come up with something. But look at that. We're starting to pass over the old Sea of Tranquility soon. All of our landing sites are going to be sort of on the dark side, to be honest. Since the solar angle's in a very interesting spot. We could look at the Earth with the sextant right now, maybe. Let's take just about a minute out to do that. Yep, we can. There she is. Oh, yeah. What are we looking at? Oh, here's Africa. Oh my god, there's... I can almost see my house from here. It's really hard to see, though. India. The South Pole. Can almost see my house from here. I bet I could almost see Flight Streamer's house from here. No, I'm just kidding. Hello, Sherry. Oh, yeah. The optics are great. Speaking of which, we have to do optics stuff soon anyway, so actually there's probably no point in retracting the cover on that, but whatever. All right, let's get an IMU align in with some star marking. Our favorite procedure. Verb 37, enter. 52, enter. Verb 22, enter. 3, enter. Pro. It wants us to acquire star 16. Sounds good. Proceed. Did that whole way home on my flight on 8. Oh, I bet. And I bet the actual astronauts did it too. Houston would be like, hey, those pictures aren't scheduled. Yeah, shut up, Houston. You're not the one flying. So, alright, star 20 is next. Took our mark on 16, and here's 20. Hey, computer, that's not 20 angular altitude degrees away. Whatever. Mark. Alright. 4 balls and a 1, that's okay. Well, literally less than a 1/10 of a degree off in alignment. That's good stuff. Alright, let's turn the lights down a little bit, huh? We paid for integral lighting. Gosh darn it, I want to see the integral lighting. Yeah, I still think that's fine, especially now that we're in a stable lunar orbit. Literally, like, 0.1 degrees misalignment isn't gonna kill us. Alright, fuel cell O2 purging. So if anyone is lurking and sort of, like, listening but not watching their screen, heads up, you are gonna get a master alarm very shortly. Okay, purging is complete. Activate secondary glycol evaporator. Roger. Look at that, we get to go in the back rooms. Dumpster diving, as Rebel would say. Open up the secret panel. Evap water control from local to auto. Terry could probably make a sick beat with the master alarm. Absolutely. Alright. Turning on the evaporator before the pump. That is definitely not correct. The pump should come on before the evaporator. So let's start the recirc flow first. Accumulator quantity drops to prevent voids from forming. Cavitation, pump cavitation would be very bad. 40 pounds per square inch discharge pressure, very good. Evap flow start, and the water has gone from solid to steam. We're making steam, we're cooling off. All's right with the world. Indicator select primary. We're gonna save, and that is going to be it. Hope you all had a great time, and I hope you enjoyed the old lunar orbit insertion. As soon as we've done our second insertion, actually no, not even. We do get to do some cool science-y stuff pretty soon, actually. Before we do LOI2 pad, we're going to do a whole revolution in this higher orbit, doing a little bit of science. We'll come back around, we'll reacquire. Actually, we won't even reacquire. When do we lose signal? I'm actually curious, because I'm not entirely convinced that this is right. Checklist-wise, I've done everything right. I'm not convinced the checklist is right, though, so let's take a look. Pad, map update, CSM, let's go for 70, 25, 00, and calculate. Loss of signal is going to be at, oh, excuse me, hold on. Let's try for, yeah, no, loss of signal is going to be at 70 hours, 54 minutes. So we're going to, yeah, we're going to come around. Then we're going to spend it basically an entire orbit. Yep, that's right. We're going to spend an entire orbit in this high orbit. We're going to come around. We're going to do tracking of Copernicus Crater 1 and Copernicus Crater 2. And we're going to do a little TV broadcast. Starting at acquisition of signal, we're going to do a test for TV broadcast. We're going to do our lunar orbit insertion 2, then at that second revolution. So that's the plan. Hope you all enjoyed. And yeah, so that's sort of the plan. Hope you enjoyed. We're currently at 70 hours, 27 minutes, 20 seconds, and counting. We're going to start calculating our emergency abort pad at 70 hours, 35 minutes, 0 seconds. And we're going to begin COAS tracking of Copernicus 1 and Copernicus 2 shortly after 71 hours, with a TV broadcast starting shortly after 71 hours, 30 minutes as a test, with LOI2 occurring shortly after that. So at 70 hours, 27 minutes, and 55 seconds, this is Apollo 8 signing off.